Guest lecturer is Simone Stefani, who is going to, well, you can say yourself
Yes.
what you are going to talk about.
Yes.
Okay, welcome.
All right. So, hello everyone. So, my name is Simone, and I was a former student. Of KTH, previous school of ICT, now ECS or whatever. And yes, I graduated 1.5 years ago, one summer ago. I will talk about Git. So yes, something more to say about myself. So I'm originally from Italy. I moved here to Sweden. I've done a bachelor and I graduated, and now I'm working in a company. We'll say a little bit more later on. And I'm working as a consultant. So I go out to other companies and help them to fix their problems. And so I see a lot of realities, and it's a very good kind of employment if you want to see a lot of different ways of doing things in a short amount of time. The first rule of this kind of lecture or workshop or something is that you should ask tons of questions, right? Like tons of questions about the topic, about Git, tons of questions about like the topic of your course, about architecture or like personal experience, and some good question also like how do I get hired where you work, or like what things that you look into people that want to go into the job market, or like what have you found challenging about Git in your team. Like ask really many questions and do it, interrupt me, that's perfectly fine. Just try to get the most out of it. That's first rule. So just to be very straightforward about what we are going to talk about, it's about Git, the whole seminar, and we'll try to catch up a bit with what's the basic of Git, because some people, I know some friends that at the time of you're roughly in the third year, right, of studies, and I know some friends that at that time they already had created their own Linux kernel module, and some people had difficulties to tackle some algorithm problems. So the skills are very, very different. So I want to just get everything on board with Git, and then we will talk about branching and merging, rebasing workflows, and how to work in teams in Git. And I think what I want to get out of this 2 hours is mostly about how Git is a tool to, of course, put your code in version control, but especially to work with other people, because that's really the big value. There's been tons of tools to maintain version code for a long time before Git, but it was not working very well in a team. And that's why Git, was the last kid on the block, has been really, really good and very successful. And we will talk about also pull request forks, still part of the working team mindset. But what we will not talk about is how to set up Git on your machine, because hopefully by now you have already. Not about clients and with graphical clients. I can say that I don't use clients for Git. It's one of the few things which I really like using Git in the terminal. But some people have very good experience. So if you feel that you're more visual and you want to use Git with clients, that's very much fine. And we'll also not talk about comparison of workflows. I will present a workflow to work in team with, using Git, and that's with it. But there are many different ways of doing it, so that's not the single way. So a bit about 2 companies. So they let me leave their work and come here. So I tell a bit about. So the first company is like I said, it's very hard to pronounce the name. It's my employer. It's a consulting company, and it's based in downtown. And what we do is that we have companies with tricky problems and one solution. So we have clients like Spotify, Klarna, and SaaS and whatever, and they want the very specific knowledge and debug the 15 levels cache layer of Spotify network stack, and we have someone that can do that, and so work. And super cool environment, super friendly. Like 98% of the people are for the good or for the bad from Kista. And half of them never graduated because they just joined the company. or founded a company. And some are trying to graduate now, so they're trying to figure out if they're all the credits after like now they are in their 40s. But super cool environment. Worked with them on many projects, but most of the people that work there full time, they go out to clients. We don't have much in-house project. Well, I working now at a client, which is called Ape Group. It's also a fairly small company, 40 people, based in Hammarby, Hostad. I have really problems of pronouncing it, but there. And they actually build software in-house, often for other clients, but they build software in-house. And I've been working on a project recently. It's a very cool project. It's support, like I write backend software for an app which is used by 30 million monthly users in 57 different countries. It's for one of the biggest companies in the world, so it's quite cool. And there I was hired as a Java developer, but I've never written a line of Java. Talking about titles, and what I've done is mostly backend ops infrastructure, and recently I've been developing machine learning models and pipelines, which is extremely boring. In case someone thinking doing machine learning is really, really, really boring. It's you spend your time going through spreadsheets, kind of like the most. Yeah, that's at the end of what you do, and just cleaning up data and so on. It's not super exciting, but you know, sounds cool when you say to friends or family or whatever. So, and if you want to apply for these companies, and if you search for a job, there's some handles there, so emails that you can reach. I will put up at the end, I guess. So, other important things about, in general, about Git, and in general about when you learn some new skills, that, so, software sometimes is tricky, and sometimes you need to do something, and you think that there is a way to do that thing, and then you're scared of going forward because you don't know what the consequences, and especially if you work in a team and you know that you're changing things for a team, then you feel, am I doing right or wrong? Just ask. Like, people are super nice in our kind of environment, and they are really up for help, and you both have higher likelihood of solving your problem, and also you will learn more because you will exchange ideas. One last remark before starting with the real presentation, I think, yes. I've given this presentation for like 4 years now, or 3 years, something, half. And I've done for this course and then the software project course of vertically developed course. And like, I realized that now that I've been working for a while, before for me Git was a thing, now it's not a thing. Now it's granted that you don't think when you use it, it's like everyone uses it, there's no much, oh, what should I do here? It's like, oh, automatic. Oh, that's how you do it. It's like if you've never written in LaTeX and then you start writing in LaTeX, like when you start writing it's all, oh, what's the command to insert an equation centered? And like spending 20 minutes figuring out. After a while, it's just, you know, you write things and you don't think about it. So if you use it and use daily, after 1 year of work, which is, or like study, which is not much time, you will master it and you will not even think about it. Maybe some edge cases or strange situations, but in 90% of it, you will really not think about it. Second things, there was a workflow at the end of the presentation that I used to think was very good. And it was very good. Why? Because I read it on the web. I mean, there was this guy who was an engineer at top company that says this is the way we do it, and many people agreed, and it even got a name. Then it's called Gitflow. Like, I mean, if you call something with a name, it must be good. I never used it in real life, and not because it's bad. It's just never been fitting my use case. So I changed yesterday or today this presentation to adjust slightly Gitflow to what I've used in almost every project. So that's an important lesson because there will be obvious things which are presented as the right way of doing something, but at the end, you know, it's good to use them as guide, of course, but then you start like, you know, polishing the corners and then, you know, making things that fits your case, and that's the most important thing. So, how many people here use Git? Like, Okay, perfect. So you have a rough idea, more or less, of how to use Git. Yeah. So I will go very quickly. So for the few people that have not used much, just bear with me with the basics. Very quickly, I will try to do it in 10 minutes. And then we will go to more like interesting things, like branching, rebasing, and so on. And really, if you have questions, even about you do cherry picking, how do you do bisect, how blaming works, and how under the hood Git works, what are refs, what are packs, how the Git engine works. Those is Git a blockchain? I got this question at some point. So, yeah. So there's lots of interesting stuff. So just ask questions. So the whole point of Git is taking snapshots of like what you do. So you write code, right, which is a set of files, and you want to keep track in time, right, of what you've been doing. And the way you do it is you initialize a folder, installing a sort of like small Git package that you don't see because there's a .git folder which is hidden, starting with a dot in the Unix system. And then that folder is kind of magical because it can do certain things that normal folders cannot do. So, for example, you can see if a file has been tracked before or not in Git, and it can see when a file has been tracked is changed or when it's the same, and can allow certain commands. So, if you want to take a file, like here a file foo.txt, which you created in your folder, and you want to take a snapshot of it, what you do, you first put it in what is called staging area. So you say, this file is something that maybe alone or maybe together with other files, I want include in a snapshot. So this file as it looks now. So git add foo and then .txt, and then the file will be in the staging area. Then when you have select either one file or multiple files or directories that you want to have in your snapshot, you say, okay, I want to make a commit. I want to take a picture. And then use the command git commit. And you have a lot of options and flags and so on, but then you will have a commit, which is an atomic snapshot of your repository or your directory situation, and it includes the changes from the files that you put in the staging area. So that's the whole story. You have your working directory, which is how your directory looks like. You have a repository, like this ledger, this chains of commits, which is your history, and you have a middle ground where you first select things that you want to include in one of the commits. You have also two handy commands to see what's happening at a given moment in time. So if you want to see what's been changed in your directory or what has been put in a staging area, git status is your command. If you want to see what has been committed in terms of commits history, then git log is the way to go. Something interesting is that all repositories, right, so are all the same. So if you have a project, right, and someone creates a repository for the project, and then you make a copy, you clone it, or you just copy the folder somewhere, there is no central repo or original thing. Well, there is one, but it's in your mind, right? For the Git system, if you start interacting with them, they are all equal. This was a big sales pitch at the time for Linus Torvalds when he was pitching Git, because before other system had the central repository, which was of course also a liability because it could break or something. If it was down, people couldn't work. If you know SVN or those kind of systems. Now, if you want to interact with another repository, right, from your to another, you want to maybe sync. It's a horrible term because there is never good implementation of syncing, but you can kind of sync, just to think about it, your Git history. You can sync your files and your status. And so first thing you have to do is add the other repository as a remote. Now, usually this other repository is GitHub or Bitbucket or GitLab or whatever thing you want to interact in the web, like is a storage system. But you can have as a remote, like one of you can create a repository, and the others, if they know the IP and they know how to reach the computer, they can set that as a remote, and they can just push and pull, meaning syncing data. So when you have a remote, you have a connection with another repository, and what you can get, you can push some sort of status to that repository, and you can. And what does it mean? So the command that we're doing git usually is git push origin master. So you git push, then you want the kind of remote that you want to target to where you want to push something, and then you have to decide your branch or your kind of line of history that you want to push. So for example, as a simple graph, we have a set of commits, 4 commits, and a line of commits is called branch, and usually we indicate we say that a branch points to the last commit in the line, right? So master is by default the branch that you have. If you create a repository and you start committing, you have lines of commit, which is called master. And if you had initialized a remote when your line of commits was here, then you have added other commits. Those commits are not synced with the remote, right? So what you do, you can push, right? You can say I want to push origin master, and then you will sync these last 2 commits with the remote, and then you will end up in the situation. Now, if you represent the Git history like this, you realize that actually branches are nothing else than pointers, right, to a certain commit. Pull is kind of the opposite idea, right? Git pull origin, it's a way to get the content that has been added in a remote get on your machine. Meaning, I'm in this kind of situation, right? I have a branch, and I've been syncing it with the remote. Then someone has added other commits, and I know either because they told me or because I used git fetch, which fetch like changes without pulling the actual changes, fetch like the reference to the changes, and I see that something has been added. So then I can use the git pull command, and also my local history will contain those changes. So it's like the pointer has advanced to the end. Last thing for the introduction, if you have a repository somewhere, like online on GitHub, and you don't have on your machine, you can use git clone and URL, and that will make a complete copy. Now, I'm saying things that are reasonable, or I'm saying things which are crazy. Like, can you follow, or like, does it make sense? It's obvious, or like, okay.
It makes sense.
Yeah, I think there's Montelus that always says never ask if people understand, because they always say that be silent and then you freak out, or like they will say that something and then you will freak out anyway. No, but so this is the kind of Git from 0 to here in 10 minutes. I can show you quickly, or do you think we can go to the next topic? Do you want to see like on my terminal how do I do these things, or please say it, like it's perfectly fine.
We can skip it.
You can skip it. Someone else says skip it.
Yeah.
Okay, cool. So then we go to actual part of branches. It's a beautiful picture. And the whole idea is that when you have a project and you have people work on different things, hopefully, if it does not. So you want to let people to take a code base and independently add like features, changes, fixes, right? And change and add code without stepping on each other's feet. That's the whole idea. So it's clear that everyone will build its own history. So that's what branch gives you. it's new lines of history. Now, the interesting thing about branches is like if you have different lines of history, how you get them together. But as we will talk in a bit. So here's the most basic things about branches. If you want to create a branch, you just say git branch, of course. And you give a name, my feature. And now what happens, it's interesting. Even if branch gives the idea that there will be actually something branching out like in trees, like if you look at Git from this representation perspective, there is nothing crazy happening. Because yes, you created a branch, but both master and a branch contain all the same information. So there is no reason why there should be two different commits. Right? However, if you then, for example, add a commit on the branch my feature, then change the branch master and add a commit, then we will have this kind of situation. Yes, this kind of situation here, where you have a common ancestor as a commit, and then there will be two directions that the code base is taking. How to change between one branch to the other? Use the Swiss knife of Git, which is the checkout command. It has triggers and things, all unrelated, of course. And you check out the branch, means that you are like, what you check out is what you're looking at. So if I want to look how the code base looks like in my feature, I do git check out my feature. Right? Yes. Make sense? So far, so good. Now, the problem is with branches. How do we get this stuff together? Right? So that's a tricky thing, right? Because then we have different code, and hopefully it's different code in different files, but maybe different code in the same files that needs to be put together at some point. So we want to merge things together. And so Git has a command which is called merge. Easy peasy, very good. I can sit on a branch, say git merge another branch, and Git will try smartly to take the content from the other branch and put into the one I'm standing on. So reasonable. So what's the problem? Anyone?
Conflict.
Oh, sorry.
Conflict.
Yes, conflict. Right. So if you change the same lines, and if Git is not smart enough, can cause conflicts. So now, brainstorming session. How do we avoid conflicts? Ideas? Yes.
Use a lock that is one. The problem is that they change code at the same place or something.
No, I mean everyone has their own copy of code. So that's the problem. We don't have the problem of different kind of users trying to access the same resources and changing at the same time. That's the problem that the lock would solve, right? That's the problem that if you have an operating system.
Yeah, but the problem is that when they merge, they have changed the same part source.
Right. Yes, but since the change happens completely independently, we cannot lock a resource. We cannot do. So you may have a copy of the code, right? And another person can have another copy of the code, and you can be one in Australia and one here, and you change the code, and then you want to put things together. So you're completely independent, and there's no internet connection, nothing. You will just have to deal with two different code bases that needs to be put together.
Mm-hmm.
So we need to think something that works. That's what the operating system does, right? When you open the file, like you have a lot of tricky stuff that comes up when you try to write to files, and Unix system, everything is a file, so everything's tricky kinda. And then you have locks, and you have like a lot of strategies to deal with same contemporary access to a resource. That's a typical thing. But here we cannot do. So here we have. So other ideas. Yes.
Ask the user what to keep and how to arrange it.
Yes. So that's definitely definitely a way forward. So you say, okay, we have conflicting files. Then I tell the user what's for each file, what line I should keep. Like for giving a file, I look at the lines, which one I should keep. Right? And that's what it does. And what Git does is it notifies our merge conflicts and tells you to go and fix things. It adds this kind of less or equal, like equal, 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 and then you have one version, then you have equal, 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 and you have another version, and then you have like symbols to differentiate, and then you get in the situation where there are smart editors, like Visual Studio Code, who figures out that and make appear a beautiful like merge conflict thing. Visual Studio Code produced by Microsoft for free. There's IntelliJ, who's produced by JetBrains, a company who's specialized in this thing, so it costs a lot of money. They've not figured it out yet. Yeah, you can install plugins that do that, but heck, you will find your horrible like merge conflicts in IntelliJ, and hope they are not in a Gradle file. Otherwise, you spend the next week fixing like Gradle dependencies if you ever dealt with those kind of things. So yeah, so you can merge those conflicts. You can manually take care of it. Other ideas? Better ideas? Greatest secret in life. You go to the freaking colleague and you tell them not to touch that file because you're working with it. That's always working. I mean, it seems ironical, but in a real project, if we talk about real Git, just talk with someone and say like, hello, I'm working on the authentication module. So if you don't have anything very urgent, then maybe you can leave it there for the next week, right? Because I'm working until I close this feature. That's wonderful. It solves all the problems, no conflict, just human interaction. Works very well. So that's another strategy. And then there is rebasing, right? Rebasing is not a strategy that avoids completely conflicts, but put you in a position that dealing with them is less painful. Now, first let's get a bit into what happens when we merge. So there are two ways that merge happens. Like in the world, there's always two of something. Right? So let's say that your history stops here, right? And you realize that someone has added some code, right? And then you have kind of two branches, right? But those two branches are not actually contain different history. So this is a case of merge, right? You may want to merge my feature into master. But master has nothing more except what also my feature has. This case, like from Git perspective, merging is just about saying that actually master contains also these two commits. So like in this picture, what Git would say is like, oh, before master was up to this commit, now master is to this commit. That's called fast forward merge. Like makes sense, doesn't it, right? And this is no pain. Like always goes well. So if you get FF, because we like a lot of this kind of initials in computer science, if Git does an FF merge, then you're fine. The problems come when you have a three-way merge, right? Like when there is two is fine. When there are three things that have to come together, it's always fine. So my feature and master have different like histories, and so there is this kind of point where things have to come together. That's tricky, right? So what Git will try to do is find very smart strategies to figure out what is good and what is not. Very, very smart. Sometimes you wonder if there's someone behind the scenes who has already thought about how to fix the code, but then Git will merge them together if everything goes well. And sometimes you will have conflicts. So this is typical message that you get. You have a text file, and it fails. And what it tells you is like, well, go and fix it. So the merge will be in progress. You can go into the files. You can make the files look as they should be at the end, and you can add them and tell Git merge continue, and then Git will try to finish off all the merging stuff that was doing. So that's one way of doing it. But yes, it's an art. I mean, there's always this guy in the team that is really good at fixing like merge conflicts, and it's kind of everyone goes to that guy. It's like you know, it's like the DevOps guy, right? That will fix all DevOps stuff, and there is the Git guy. Yes, so one has to fix them. That's it. But to avoid conflicts, what we can do, we can try to never happen in a situation where we have this kind of diverged history. So we can say every time someone, if I have a master branch, right, and the master branch I see that advance because I talk with friends, colleagues, I go on GitHub or like I pull the changes and I see that someone is adding stuff there, then I can try always to make as if my own changes were done from the last change of master. So what does it mean? I'm in this situation, I've seen that changes have been added to master since I made my branch. What I want to do is try to make always end up always in a situation where like my feature seems as it was branched by the last commit. Because if that's the case, then every merge is a fast forward merge because there will no difference, no things in master that have not been yet in feature. So rebase tries to do that. And if you do it frequently, then you don't end up in the situation where master, you're pulling and saying, well, there have been 685 different commits in master that are not in your branch, and you have to merge it, and probably like the whole code base has changed in between, right? So you can rebase constantly, and that's a really good strategy. It's cheap. Only few things about rebase is that when you rebase, Git is one by one putting all those commits on top of the current branch on which you're rebasing, meaning that if the single commit conflicts with the changes on the master in this case, then Git will try to ask you how to solve it. But the good thing is that you don't get those conflicts accumulating and becoming unmanageable. So you can rebase, and Git recreates new commits with the same content but with different hash. So that's kind of some tricky things. Which means that if you already pushed your own feature branch to a remote, and if you rebase locally, then you will need to force push because like your remote has different commits. Because when you rebase, you create new ones. Bit tricky, but it's pretty cool. There is also like usually, yeah, the Git conflict merge guy is also the Git rebase guy. Yeah, so don't rebase public branches. Like I heard of people fired because of their rebase master. I think it's impossible, especially in Sweden, but I can believe that some people got really annoyed because someone has rebased, even by mistake, public branch. And why is a problem to rebase a public branch?
Changes history?
Yes, true. And this at the end means that someone has been building on top of that branch, and like there is a very fun gif of like a Pink Panther which is cutting a tree, and then the whole earth is falling. That's a kind of same situation, right? You're taking out the ground of someone else, right? It's a public branch, someone has added commits on top of it, and then you're just getting rid of it. So this is a typical example. This is like don't do it, you will get fired example. That's a feature branch. There's a master branch. You're basing the master on the feature. Now, there's probably other 15 people have been building on this that will see this part of history suddenly disappear. Like, kinda, right? And it's not really good, not nice. So, no public branches, like development master. If someone rebase master, interesting question. Should you fire them? Opinions?
Yes. No.
No? Why yes, why no?
It could be a mistake.
Yes, okay.
Probably a mistake because you were in the wrong branch.
All right. So I have a theory. You shouldn't fire them. You shouldn't fire the guy who has set the permission on Git, because if you have a decent organization, a decent like company, no one will ever be able to rebase and push. Of course, if you rebase your own master, then okay, fine. But if you rebase something and then push it to GitHub, right, for example, then that's the public so-called history will disappear, right? So if in your company, like you are allowed to push directly to master or to rebase master and push it to the central repository, making actual code disappear, then yeah, unless the same guy who has rebased is the guy who set the permission, then you should fire the guy who set the permissions. It's like, when people, have, the intern logged it into our production database and dropped it. Yes, he was not very smart, but the guy who set the permission to access that database is the one to blame. So that's kind of my theory on these things. Fork and pull request. Some small things here. Someone created a repository, like your favorite package. What's your favorite package? Do you have a package or like a library that you use from GitHub that you think is interesting? Anyone? No? Never pulled the package from GitHub? Or like from Maven or whatever? Hex, RubyGem, Python, something. No? Okay, well, okay, so you have, I don't know, Webpack. Or the web is modern, or we have a lot of trash in any web app, and so Webpack is the thing that takes all the crazy new framework of the day and crunch and make HTML, CSS, and JavaScript. You decide that you want to help the Webpack guy to develop Webpack. And so you want to your own copy of his repository. So if you damage it, it's your own copy, but it's of that repository. So, and that usually you do on a public version control system, or hosting system like GitHub. So if you go to GitHub and you go to a repository, I think this was actually the Linux operating system mirror repository, you can make a fork. Means that your own GitHub account will have a copy of that repository. Okay, before I get to pull request, does this make sense? Any question, anything that I say that was weird? Like, say everything, like, really.
Why do you branch if you can do a fork instead?
Yes, true. The reason is because if you use branches, like first of all, like fork is something that you will not use if you kind of work alone. So if you work alone, you want to maybe still work on different features at the same time and then change between one and the other. And also because I would say that forking is quite an overhead. Like if you make branches, you have main branch, right, master, and then you make different branches, different people work on different branches, and then you merge in. Okay. If you have forks, you need always to pull and sync from other repositories because each fork is a kind of own repository. They're a copy of the same repository, but are physically different repositories. So you need to, I want to set a remote to my friend Bob repository, and I have to pull something. It's cumbersome. So that's why fork is actually fairly uncommon unless you're working on open source. So there are very few companies which have internal workflows that involve using forks. If you do open source, on the other hand, it's like almost every workflow and every open source maintainer uses forks because you want this kind of independence and separation. Other questions? So no one is asking me if I have a rebase master. It's very good. Let's do it there. So pull request. So what's a pull request? It's there, so it's the image, so I cannot even ask because it says everything here. But essentially, you're saying I developed a bunch of code on my own branch on the same repository, or my own branch on another fork, whatever. I want to request someone, the maintainer of the code base, to pull it in. Right. So that's it. Now, it's not only a technical thing. It's absolutely not. Like the major part is not technical. It's just that, if you're writing serious software, there's a lot to talk about when you add something or remove something even more, right? So pull request is a way to integrate own code into the main code base and to talk about that, to interact with people, to change things, and so on and so forth. So this happens, for example, in GitHub. Right? If you go to GitHub, someone proposes a change in a code base and makes a pull request. Right? And then people say, oh, I've tested it, it's fine, good. Someone says, oh no, I think we need to change because it doesn't support that version of Internet Explorer number 6 because everyone uses it. And that's what is about the pull request. Cool. So in 5 minutes, I can show you 3-4 things in the terminal, and then we can take a break. And please ask really questions. I will repeat continuously until you just ask questions to make me stay silent. Not ask again. So right. So nothing crazy. I have a terminal open. It's like your terminal, it's just with colors. If your terminal doesn't have colors, it's not full green. It's nice. It's like bash, ZSH, so something that you will probably find familiar. I'm in my home directory, and I can create a folder. So I mean, nothing crazy here as well. It's called project. Let's get into project. And is empty, right? So nothing interesting here either. And what I can do is if I run git, it says so there's nothing here about git, right? Yes, there is a git command, but there is git status. It's not a git repository. There's nothing interesting there. It's completely empty. I can create a file. Foo.txt. Cool. So now there's a file. Still not a git repository. I can make a git repository by initializing it. So interesting. So now you see some magic, beautiful things there. You may not have on your machines. Those are just like, you probably don't get on which branch you are and things like this. There's a terminal configuration, but it's nice to have because then you don't end up rebasing master or merging master into your feature and things like this. So now we have a git repository, because if we look into what is in the repository, there is my file, and there's the mysterious.git folder. Nice. So still, if I look at the log, right, there's nothing in there. There's any commit, and if I look at the status, it says, Git likes to say a lot of things. Say that I'm on branch master, there is no commit, and there is an untracked file. And so what we want to do is to track this file into Git. So put this file in version control. So nothing simpler than git add. And now this file is in the staging area. SD is my alias for status. Just use it. So now the message changes, say no commits, but there is no untracked file. There's a file which is soon to be committed. Nice. And I can commit it. And I can add a message for the commit. If you don't put -m, Git will open the terminal, the text editor of choice, and will ask you to input there. And of course, very unfortunate for everyone, the text editor of choice on Unix is very often Vim, which is a pleasure to work with, if you can. So you can input the message here, and very easy, like usually everyone is short of ideas when it's first commit, so everyone calls it initial commit. There's no project in the world that does not has the first commit called initial commit. Doesn't tell anything about what you're doing, but fine. So yes, and it's telling some interesting things. Says okay, you made a commit, blah blah blah. It has a kind of an ID which is a long string of characters, and it doesn't contain anything. It's just committing a file. There is no content in the file. Perfect. Good. If I do git log, Good. We have an initial commit. It has that a hash, we call it, which is good. And we have something in version control. Now I can edit that file. Some text. Boom. So what's happened now? File has been changed. File was in version control, still in version control. There's some new changes, and I want to track the new changes, right? Cool. I can git status. See, file's been modified. Good. I can see the difference.
Does Git do a checksum on all files in the directory? Just to look, see what files are
Git
changed?
does very smart things, very obscure things. Yes and no. So like how Git, no, it doesn't do on the whole folder structure, right? And that's why Git is very fast. But has a lot of very smart ways to tell if things have changed.
Okay.
For example, it represents a lot of things as trees, right?
Mhm.
And if you do a change, it looks if like certain paths, like have been changed. So instead of like snapshotting everything and like checking every single file, it's if you change something, it figures out like which path has been changed, and this kind of sort of tricks.
Do you know exactly how it knows which file you have changed?
I would not be able to. I would be uncomfortable to explain it.
Okay.
But like what it does, it's a bit it's used like things like called like. Okay, I shouldn't be uncomfortable since this was my bachelor thesis, but was 1.5 years ago. Use a data structure called Merkle trees, which is, by the way, the same data structure which Ethereum and Bitcoin blockchain use under the hood, and which other many smart things use under the hood. And it means that at every node of the tree keeps hashes, and it essentially needs only to. It needs to recompute a lot of hashes, but it only needs to verify certain hashes. And the reason is because if you change something at the bottom of a tree, right, the hash that is generated at the node is a combination of what's at the bottom of the tree, right? So that hash would break, and all the upper ones would break. So yes, it computes of a lot of objects, but like it's kind of quite smart the way that it kind of figures out at what point like a chain of hashes have broken. Like I don't know the case of Git, but like that's the kind of Merkle tree theory. Like you have a lot of like nodes, and each node is a combination of hashes, and those so on and so forth, and then you can tell like when if one single file has changed, has broken a whole chain of hashes. But I don't know exactly how Git does this check.
Okay.
Yeah, that's my answer. But it's very interesting. Yes, definitely. What Git use, like Git has 2 layers, if you are interested. One is called porcelain, and one is called plumbing. What we are doing now is porcelain, and there is a layer of Git called plumbing, which is raw commands that generate hashes, build trees, and so on, which you will never use in a real project. It's just if you're curious about how things Git works inside Git. And that's like the place to look into if you want to see. And there is always the last chapter of every book on Git is about planning. Yeah. But yeah, so back to what I was showing. That's a diff, just saying that before was nothing, now there is some text. Yes, I will maybe delay a few seconds. Cool. And show just a branch, so we can make a commit. Cool. I add first the file, see, and then I make a commit out of it, right? So now if I look at history, I have 2 commits. Oh, I misspelled it. And if I use my find commands, I can see this is a kind of compression of the history. There was initial commit, and there is a second const change, which is where I'm looking at. Head means what I'm looking at. Now, super quick, I can add a file to, I can make a branch, get the branch feature, I can say git, yes, this one. Again, now I have still 2 commits, master and feature. I'm looking at master. I create a branch, but they contain the same thing. I can check out the branch feature, right? Now I'm on feature. My terminal tells me that I can add a new file, part.txt. Oh, cool. Second file, saved. There is a new file. So if I look at the status, there's a new file on this branch feature. I can add it. Add commit. Cool, everything is clean. Now if I look at how my structure works, master is still back in time. The feature branch has a new commit. Now how do we create a branch? I can go back to master. Yeah. Cool. I can change again the file foo, for example. Yes. Text. Cool. Git status. So it's this. Some changes. Git add. And git commit. Cool. And here we are in the situation of a branch, right? So 2 different commits, 2 different branches. So now I can merge it, right? So conflict yes, conflict no. No? No? Everyone's for no? Good. I change different files, so it should be fine. And I merge feature. Yeah. Now I didn't get to use it. Oh no. Oh yeah. Cool. So this is as usual. Now I have the master, which contains changes from both the branches. Like, yeah, it's just a branch and then merge together. Quick thing, I want to take my master branch back to this commit, right? I want to just remove that merge, remove that single commit which englobates both the changes. I can just reset, and I can reset hard. Cool. Reset hard means that we move the history back to that point, and we remove the actual changes in the file that have been introduced by by the commits that were in between. So if I look, still back in the same situation, right? I remove that merge, I'm back in the same situation as before. Now, what's the other strategy that I should try?
Rebase.
Yes. So this time, to merge, you are on the branch where you want things merged in. To rebase, you want to go to the branch that is get rebased on top of something else. So I go to code feature. Yep. I have a lot of aliases because time is precious. So co is checkout, of course. So I'm on feature. I can sit here. My head points there. And I can rebase on top of master. Cool. So it says something very mystical. Rewinding had to replay your work on top of it. Very clear. And that's rebased. So now the feature is as if it was made on top of master, but the commit is the same. Sorry, has been changed. It's a new commit. Now, what's the last step? I check out master, and I can merge the feature, right? And it says the magical word, fast forward. No need to merge commit. Like, if I look at how the history is, it's beautiful. It's a linear history, right? Yes. So now we have all the changes. The debate between if one should merge or if one should rebase and fast forward is the Git equivalent of Nikos versus Canon, of Mac versus Windows, or Vim versus Emac, or tell you thing, because it's kind of, you know, set developers a bar on a beer. That's what they talk about if they like it. But that benefits. Some situations force you in one, some in the other. So yes, I taking even too much time. So in 50 minutes back. It's fine. Cool. So yeah, 25. Time is going by. Blah, blah, blah. Yep. So now. You know how to use Git perfectly, that's fine. Alone. And you need to work with people, because the world is full of people and people are nice. And also because the employer wants to do that. Often. Yes. So you want to discuss with your team a kind of general workflow that people will follow, right? Because you don't want everyone that believes that there's a special snowflake and has own way to do things, and that's it. So you want to have a discussion, and it's also this kind of discussion that, you know, goes on forever. So probably put in a time box it, and you get with a common routine, right? And yes, workflows. You come up with workflows, and you pick one, and you don't agonize forever on which one you pick. You pick a reasonable one, and if it doesn't work, you adjust it. Easy peasy. So I would recommend Git flow, or like the modified after paid version of Git flow, which is very common. Anyway, so there are two parts in it. One is like conventions, and one is what you do with other people. Conventions is that. So I'm going to be quick. So branch conventions. You have certain branches, right? And branches have names, right? So master is the branch that it creates by default when you create a repository. And usually when you have a service, a web app, or anything, master wants to be the state of the code that you deploy, that you release as an executable, that you push to a server, that probably even better if you don't do that, your CI does it. But anyway, the thing that is live and people are using, right? So that's master. Develop, it's like a branch where developers like merge their own work so that it creates a certain amount of new features or fixes that will eventually end up into master. Now, I thought this thing was definitely a sacred thing, right? Like, it's master develop. Like, you know, everyone is using, no one, people are using, masters you get for free. Develop, well, you know, 50-50, other people I work with use it, others don't. You know, that's fine. They figured out a better way. They feel comfortable. Very good. My current client who I work, we don't have develop in any. We have 6 different testing environments, and that's it. And when things pass on those testing environments, which have very specific features, then things get merged into master directly. And we had virtually 0 problems so far. But anyway, if you follow the Git flow with develop, which is still very nice, master, these are times the code was released, you probably want to add tags, right? And then you have feature branches. Features branches is you that decide to add something to the code base. You do git, checkout, branch, whatever, and you get your own branch. Convention, you branch out of develop, and you will merge into develop. You call it features / something. And yeah, so that's it. So that's the case. You have two features, you have a small feature, a large feature, you branch off from different commits, fine. Now, this thing is, some people think that this thing is a good idea. So what they do, they're in develop and they say, let's merge into master. But maybe we need to do some small adjustment before we merge into master. So they create a release branch that will go into master. Now, this is part of the manual how to do the things right. It has always messed up my work. So I will never use release anymore. But know that many people think that release is a good idea, so they have a release branch. And a lot of, especially libraries that rely on, people have expectation of what will get out, they have a release branch. And there's kind of a feature freeze on this branch, right? So people go on developing features on their branches, and they freeze new features on release, and they just fix bugs that QA, quality assurance team, will come up with. Hotfix, that's what you don't want to see, but unfortunately, the world is far from perfect. So this is the case where you've just deployed, and your phone rings, and yeah, the number is a client number, and it says, hello, doesn't work. And I'm absolutely assured that they will not ever be more specific than it doesn't work. They will tell you it doesn't work, and you need to make a fix, so you have to just, figure out what's the problem. And then you make a commit. Now, the question is, where will you make the commit? You can make in develop, but then that will take time that gets released, right? So what you can do, you can merge directly into master, and then merge directly into develop. So straight from there. This may cause like merge conflicts, especially with develop, right? That's fine, because if your clients get so pissed off that drops you and your project, then you will not have a job that is worse than dealing with merge conflicts. So yes, shouldn't happen, sometimes happens, then we merge it directly into master when we fix something critical. So what's the big pictures behind this? So you're starting a project for this course, and I don't know if you do, I guess you do in groups or teams or like pairs or something, and someone will create a repository. You will add the README file in the repository because it's good practice to do so. You will add a git ignore so you don't check out all your dependencies, all your secrets and stuff like that into your repository, because that's very, very bad. And then you have a starting repository with, and I don't know if you're building a Java app, you just install Gradle or do whatever IntelliJ does and don't care, and then you will commit it. Create Git repository, commit it. And then you push it. You push it to GitHub, because GitHub comes for free if you're KTH. So you push it there. You've created a repository there, and you push it. Cool. Now you have the other people. What the other people do? The other people will either clone, if they've not had a copy yet of the repository, or if, let's say that they've already cloned the repository itself, they will just pull. So they will get all those changes on their own machines. So they have a folder with the same name, containing the same files with the same history on their machines. Right? So developers work on their features, and everyone does commits. Possibly they work on different branches, don't add stuff to master, right? And what they will do, they will then push, and will push to that remote that is kind of GitHub, for example, and then they will go to GitHub and make a pull request, right? They will make a pull request. So, yes. And the pull request will be discussion. Merge yes or merge no. So the developers, like when you do a pull request, you ask other people to review it, right? And if it's good, it will be merged. and if we use the previous flow, will be merged into the valve. So, very interesting. That's the situation, approved and merged. Then, if you pull, then you will get those changes that have been incorporated in the code base. Does this make sense? I don't know if it is not. No. Is there any question about this? Is it reasonable? Okay. All right. Good. So I can show you a couple of things. Now, I have to very hard think about a repository which will not give out secret stuff or like, you know, proprietary stuff. And I think more chance with my company, like my employer than others. So a bunch of stuff. Let's say this repository is a React app. Some pull requests. Yeah, let's look at closed ones. Move on. So this is a pull request that I made, right? So I had some code, right? So I refactor some code because, you know, that's a good thing to do. Everyone says that. So, all right. I had a copy of the repository. I made my own branch called feature refactoring. And then I went to GitHub, right? I went in pull requests and I say open new pull request. And when I open new pull request, it asks me to, it contains changes in the files, right? So there are a bunch of changes, right? If you're doing React, don't do React as people were doing 5 years ago. Use hooks, is modern thing. So we changed to use hooks and you know, refactor a bit the code. And then I create a pull request. I usually add a description if I'm adding a feature. It's a really good thing to do. You can even have a template of the descriptions. Here was a refactoring, so there was nothing new added and nothing. So, but really add a description. I asked two colleagues, Albert, has been a lead engineer at Spotify, and is a colleague, and he reviewed some stuff, and a friend. And then I add some labels. Nice to know that, I mean, if a person has to review a gazillion pull requests, right? Then if it's enhancement, it's okay. But if it's security, then probably priority of a review will go on security pull request than enhancement. So if you, GitHub gives us labels, so it's quite nice to use. And yeah, then Albert approved, and I merge a pull request. That's how a happy flow goes. Some interesting thing. Let's see if I can get an open pull request. This is a bit special one. But here, there are a few things interesting. So, and here we go a bit away. This is the last thing I will say, so then just think about your questions. But we go a bit away of Git, because Git is just a tool in your machines, but then you want to build all the team workflows. So you use Git and use some other service that will offer us modern ways of doing things, right? So most of the people pick GitHub, like you can pick Bitbucket, GitLab, doesn't matter. We use GitHub. We used to use Bitbucket, but we didn't like it recently, we changed it. Right? So some features, most of the managers like GitHub and Bitbucket have them, some they don't. So I have put some constraints on this repository. So for example, people cannot merge things which don't have at least one review. And checks passed, I will show you what they are. And that they are out of date with the base branch means that out of date means that they need to be rebased, because otherwise there could be conflicts. What are the checks? What are the checks? Yes?
Could be continuous integration.
Yes.
Things like Travis looking at things.
Yes. But nowadays, even GitHub has a CI. So GitHub has GitHub Actions, it's their own CI, or Travis, or Circle CI, or if you are very unhappy in life, you can choose Jenkins. And you know, you have workflows. It does all the things that you need to do. It's just, I don't know, you know, pull, audit dependencies so we don't have vulnerabilities, links so we don't write some four spaces, some 2 spaces, some 3 because we want to find a compromise. Like, very good. It has even deployed it. So this thing, I think, gets deployed to some AWS beanstalk. I don't know, some disgusting things, but anyway, deployed it. So this is not the same pull request, but very good. So you don't want a pull request to be merged if it fails on your CI. Because if it fails on your custom testing machine, it will probably fail also when you deploy it, right? So here we are at the point that Git, which was just a simple tool, personal use, few people use, has a whole ecosystem on top of it, where you build like a lot of like workflows that support a really good software, right? Meaning working with people, discussing things with people, meaning having your code review, so possibly you improve your way of writing code, meaning having machine checked stuff. Yes, so I think this is super important. So after learning it, or at the same time, learn also how to use the wonderful ecosystem that's around, and just not see it as oh, it's like a hammer that I put nails in, but it's a whole thing that helps you really create better software. That's why everyone is using it. So this is kind of the recommendation. This is all I want to tell, also because I want to leave a bunch of time, like it's 20 minutes left, for questions, or like every sort of questions. I will say random things if you don't have questions, so if you say question, you have more chance of talking something you're interested in. Good? Nice. So, what is anything that you want to know about? Yes?
Like working with Git at your job and so forth. Are there any like common mistakes people do when using Git, and like how do you have any methods for like solving them? Like the most common things that people do?
Yes. I would say get a good workflow and get people to use it. And I noticed, so these as you may figure out, are not technical things, because technically it's a fairly simple tool when you get wrap your minds around it. It's more like how we use it, right, as everything, and how we behave with other people that use it. So one typical thing that I noticed is that the guy that I showed before that was reviewing my PR, Albert, and there's another guy called Björn. They're extremely good engineers, right? So they've been working, as Spotify for 5 years, right? And like debugging core stuff, or like fixing core stuff. And they just find this is fun to work for a small company where they can change job very quickly otherwise. So they're really good. And yet, when they make changes or fixes, if you look at their pull requests, they're small, they have a long description, they have always documentation and tests, and they ask even to the most junior developer in the company to review them. Which is something, right? You've been like coding and contributing to open source for 15 years, and you ask to this student that has never done has done only university stuff, like that works part-time at your company. That's not me, but like we have people that at the moment work part-time to review your code. That's really, really big maturity. That means that you think that criticism from any person is really good, that you want to trust others and make others participant of the work that you do. Really good. Developers, not bad, they do their job. There is a 65 files change commit with 85,000 lines of change. And you go at it, and you go to the pull request, and you see creating 1345, merge 1346. No reviewers, no CI, no tester, no documentation. So choose the developer you want to become. When you use Git, it's the kind of, or like GitHub where you work with it, and you interact with the people is the moment where you really show what kind of person you are, or what's ambition of what kind of person you can be as a developer. And like, so one common mistake, think that is just a tool, that is what you're doing, you're on top of it because you're done before, you're confident, and just, checking code, check minimum testing, like manually that works, merge in, fine. That's no good. Very good. Be very explicit, involve other people, and just be humble and try to grow from the criticism that you get on peer reviews. Does it make sense?
Yeah.
Good. Other questions? Leif? No? No questions?
Yeah, I have questions.
Yeah.
What do you look for when you're okay? If no one else has a question, how much time do I have left? I can ask questions for a long time. Can you tell us something about the hiring procedure? Like what?
Yes.
I assume this is interesting. What do you look for in new employees?
Yeah. So it's quite interesting. It's a crazy world out there, right? Every company, as you know, searching for software developers. Like we're searching for software developers all the time. But the thing is that if you try to search for jobs, you will find it's very hard, right? And you ask yourself, why? Do you have any idea why? Why everyone says that is searching software developers? You read every statistic, so follow any course about future career or whatever, they tell everyone is searching. But then if you search for actually real jobs, it's not so easy. Why so?
HR.
That's exactly the answer. No, that's part actually is tricky, right? It's, yes, not everyone understands exactly what are the requirements. Other ideas?
A lot of checkboxes.
True, that's part of HR. No. Yes. Other ideas? Yes.
Where you find the job application, or
Right.
if it's contacts or
Yes. Yes. But I would say that the tricky thing is that when people say that they're searching developers, they're not saying they're searching any developer. That's a different, right? So the thing that is very hard is because like companies have a certain idea and a certain needs, right? From the people that they hire. And there is a very big discrepancy between, or like tends to be a big discrepancy between like what people either can offer or communicate that they can offer and what the company wants. That's kind of the tricky thing. So we hire people, and the way we do, we are definitely not perfect. Actually, I think we are not necessarily super good at it because small company is iteration is not super fast. You don't have big departments and so on. So first of all, we have been hiring a lot of students from KTH, and it's kind of been the bet that it's better to get some young people that have to build experience, right? At the beginning of their career, that they can grow with you, than hiring someone who is a super experienced developer who has already figured out everything about life, like later on. Right? You want a mix, kinda, but it's also really nice to hire young people. And when you hire young people, it's trickier because they don't have previous job, right? The typical thing is like the 8 years of Java development, right? Or like the 8 years of Elixir development, and Elixir has not been out for 8 years, or like not publicly out for 8 years, kind of thing. There's a lot of stories about these things. So you cannot have this reference. You don't have previous job. You don't have the X year of the checkbox, so the X year of experience. So we try to look at other things, and the typical things is like the Google way, like the problem-solving skills. So the things we do is send the cut-test assignments. So 3 cut-test assignments, 2 mediums, and 1 hard. Solving your language of choice. Hopefully not C++, because if you solve in C++, then we have to like the people that will interview you will try. No one will want to do that, but some people do it. So anyway, you solve the language of choice, and then we interview you, technical interview, and we talk to you, and we go through some problems at the whiteboard. Often. So one thing is problem-solving skills, which is really good. So do cut is do HackerRank, nice, but it's not all. The reason why it's not all is because you will never get to implement variations of Prim's algorithm to solve problem network, because unless you're designing routing for Google, that's not the case. So that's only a measure, a filter. Then we talk about what you can show, right? If you have a photographer that you're going on the market, you have a portfolio, right? You come with a book and you show your pictures, right? That's it. If you're a developer, what you do? Sorry?
You put it on GitHub.
Yes. So you have your own portfolio. You have a nice collection of repositories. Doesn't matter if it's cool projects. That's fine, right? You have a nice collection of repositories that you can show off and present to an interviewer. That's really good. Don't put them on KTH GitHub because you cannot access them, by the way. Anyway, so you have a collection of repositories and nice collection of repositories, meaning that dumping the code there is not definition of nice. Means I do a course, I write a nice README, right? I put the code there, I don't check in the credentials, I don't check in the dependencies, right? Even if the teacher doesn't ask me, I write 3 tests to say, hey, I've written tests. I'm an expert of tests. You add the CI, it's for free, it's inside GitHub. You just take your code base, read 3 lines. Oh, this was not one. You write 1 file like this, easy peasy, nothing to do. It's a list of things that I have to do. I need to pull the code, install Node, run the test. There is a beautiful documentation on GitHub how to create GitHub actions. If you like Travis CI, you do Travis. If you like Circle CI, if you like Jenkins, Jenkins is unfortunate, but you can do that as well. And you have a real project. It went from a study project to a project which has everything that can be actually in a real life project. And when we are at the table chatting on an evening about your future work there, you can talk about this. And you have something to talk about, something to show off the quality of your work. And this is taking 3 courses of your choice and making them nice and published on GitHub is like 1 Saturday afternoon. If you have to learn from scratch CDCI, is maybe 2 afternoons. And you have increased of like 60 or 80% the probability of get hired from someone. So super low hanging fruits. So that's how we hire. We hire experienced people, but a lot of junior people. If they're senior, there's previous job, there's X years of experience in this thing. If it's junior person, what have you done, right? How can I see it? How can I assess your quality? That's what we do. And that's, ironically, the same that we do at our company, that we do at a client, and that I think many more companies are going through that direction. Because there is never enough developers, not everyone can hire senior developers, so many people have to hire more junior people. Out of school, this is super fine, super cool. And then those people need to have something to show. Does this make sense? Right. How does your GitHub look like? Have you improved? So yeah. So that's what we look at. And we had interviews which lasted 50 minutes and interviews that lasted 3.5 hours. But we hired that guy. Was like scheduled 1 hour at 6 to 7. At 9:30 we left because we thought that was, otherwise was borderline forced labor or I don't know. But it was long, not because he was not good. He was just had a lot of ideas, a lot of discussions. Super good. Fine. Other questions? For example, what other skills beside Git are interesting to know? That's a good question. So maybe you want to learn Docker, if you have heard of it. Yes or no? Containers. Everyone is doing everything containers because it's cool. Yeah. So like, there's a bunch of these skills, like how to write tests, right? It's not easy. It's very hard to write tests. How to write tests is a good skill. How to set up CI is a good skill. How to do Docker. It's cool. How to use Git. It's very good. And how to sit in front with some colleagues on a whiteboard and look at the requirements of a client and draw boxes and come up with something doable is also a skill. That's exactly what you do in this course, right? Isn't it? Like the architecture, software architecture, no?
Yeah.
Am I correct? I'm in the right course?
Yeah.
Yeah.
It's, at the end, it's just, drawing boxes. UML diagrams are boxes. Never use them UML diagram. Always use boxes. And that's what you do. So this skills very good. It's a programming language is like whatever. No one cares. They say they want 10 years of Java. No one cares. It's Java today, it's Kotlin tomorrow, and whatever comes after. Right? So yeah. Cool. Please, if you have other questions, otherwise I will let you go. It's good?
Yeah.
Awesome.
Thank you very much.
Nice. Thank you.